Hello, and today I'm going to be discussing the evolution of the cardiovascular system and the heart in animals as they are transitioning onto land. So here in this slide we can see some of the changes in the cardiovascular system. Some of the challenges that are now creating is the gravity blood flow, also the support of the body, locomotion of an animal, water loss, temperature, and energy. And some of the advantages that we do see are the reducing the drag and also the increase in oxygen uptake. By looking at the circulatory system, we can also see some of the changes as animals transition onto land, which include an increase in blood pressure, the valves that evolve in the venous system. The heart is moving posteriorly on the animal. A three-chambered heart now allows for the separation of oxygen and deoxygenated blood. And we also will see some of the blood being mixed. The low pressure is happening in the lungs, while the high pressure is occurring to the rest of the body. And even some vertebrates can direct blood flow and pressure to the other parts of the body. So when we look at the early vertebrates and how their heart and cardiovascular system change, we can look at the poralepiforms, the osteolepiforms, and also the opisthosteigids, and we see that they're sarcopterygene fish, closely related to lungfish, and they lived in shallow waters with a two-chambered heart partially divided. The reason that it most likely evolved was to begin that early transition onto uh, terrestrial land. Having the two-chamber heart and what it set up in the future allowed for separation of the blood flow from the gills and the lungs. It also set the stage for the support for gas exchange in the gills and lungs, as well as higher pressure once these vertebrates were transitioned onto land. One of the things that I read about is their ability to obtain oxygen straight out of the air for a redesign of the gas chamber. Is most likely one of the evolutionary mechanisms that was involved in the change to the heart in these life forms. The tiktaalik was mainly known as a fishapod. Occurred after the poraliforms, and same thing. They would live in shallow waters. They would need to support themselves in both a water and also a terrestrial environment. The Echithostega and the Acanthostega, same thing. They needed to adapt to a transition of both shallow water and also their lung circulation on terrestrial land. When we look at frogs and amphibians, we can see the change in the heart as it now has a three-chambered heart, and even some amphibians, much like we'll see in the next slide, have a three-chambered separated heart. So the atria is separated, and there's still one single ventricle. It contains a spiral valve that can be directed into the correct atrial arches. In the frogs, the oxygen and deoxygenated blood we can see being mixed in the ventricle, and also in the three-chambered septated heart it's partially mixed. And one of the reasons why it most likely evolved and adapted onto the terrestrial land here is just for better oxygen regulation. The higher pressure in some of these animals would also need to be increased based on all the disadvantages, or not the challenges that these animals now face upon coming onto land. With the amphibians and their double circulation, they did, like I said, have some sort of mixture in the blood, but it was only partially mixed. And as we see with the turtles in the next slide, go into a little more detail. So as we see on this slide with the testudinids, or the turtles, when we look at the heart, we still see that there are 2 atria and 1 ventricle. And the difference here is when we're seeing it is that it's partially septated. So there is still that mixture of oxygenated and deoxygenated blood occurring in the ventricle. And as we'll see in a little bit, the ability for the turtle to change it depending on what activity they're doing is what creates that change. The turtles do have an incomplete ventricle system. Again, with the changing in the mixture of the oxygenated and deoxygenated blood, that's what we'll see. There is an increase in the systemic blood flow from the deoxygenated blood as it's diverted. And we can see that in the pictures over here during the air breathing and also the diving activities. Winekin described them as episodic breathers. So that shunting that occurs during different activities is what's going to cause that to change in the heart. And what it is it's reducing the blood flow that's occurring in the lungs during these dives. And it helps because there's more oxygen being absorbed and removed out of the blood during these underwater activities. And then when they come back up onto land, we can see that the blood is changed again in the heart system. So it is that shunting that changes for the turtles during these 2 activities. So as we try to recap some of the different clades that we can see in the evolution of the heart cardiovascular system, we can start with the porolipiforms, the osteolipiforms, and the stages. Closely related to the lobe-finned fish, primarily with a 2-chambered heart. We can see it adapt to this ability to breathe air into the lungs. It still has the gills, but we can see this transition to more function with the lungs. On the tactilic, we see that fishapod that is starting to come onto land. It's propping itself up. It's still living in shallow waters, but the cardiovascular system is now beginning to support both forms of the water and in the air. If we keep moving down to the Ichthyostega and the Acanthostega, same thing, living in water and on land. The hearts are now separating into those 2 different chambers, and there is the mixing of the blood in there. On the reptilomorphs and the tetrapods, we see that 3-chambered heart evolve with the 2 atria and 1 ventricle, and there is that partial separation, but we're still getting the mixture of deoxygenated and oxygenated blood, and the pressure that's happening in the heart is also changing during this time. Amphibians, as we move along, 3-chambered heart still, mixing of the blood. It's still part of the aquatic life and the terrestrial life. It's beginning to kind of develop into other things like the testudinids with the ability to have that separation during different activities, the shunting during those activities that they have, and we can definitely see the changes as we go through between the 2-chambered heart, the 3-chambered heart, and also the 3-chambered heart that's septated.